We are in lesson 29, looking at page 367. And in this lesson, we were working on describing functions. And we were describing functions based on their visual with specific words like domain and range, increasing, decreasing, and constant intervals. And increasing intervals are when the graph is going up, kind of like a positive slope if we want to view it like that. Decreasing would be the opposite when it's going down to the right, like a negative slope. And then constant would be where it's not changing, aka a flat line. So what we're going to do right now is we're looking at a graph of g of x over here on the right. And that is our graph right there, represented by that red piecewise function. And I'm calling it a piecewise function because this graph right here, although continuous from the left side to the right side at this end dot, is made up of three pieces. This positive sloped line in green, this negative sloped line in blue, and our positive sloped line in purple. And again, keep in mind that all of these are g of x, hence why I've titled this entire function, although made up of three pieces, one g of x function. All right, so let's take a look at what we're working with here. I want us to evaluate or figure out what is g of -1. And keep in mind, y'all, that would -1 it is the replacement for the x. So basically this question is saying, what is g of x when x is -1? So what we're going to do is we're going to cruise over here to our graph. We're going to look on the x-axis where x is indeed -1. And that leads us to right here at this point. When x is -1, we are there on that green portion of our graph. And what is our output, our value of g of x at that point? Well, the output is 0. So when x is -1, g of x is 0. Cool. Easy enough. Let's move on over to number 2. What's g of 3? So same logic, but now we're going to find out where x is 3. So we're going to cruise over here to our graph. Oh, there's where x is 3. Sweet. What is the g of x at that point? What is the output or the y value? G of x is 2. So when x is 3, we are at a height of 2 and output of 2 on our graph. We are evaluating or solving for the height or the output of the function by looking for specific values of x, -1 and 3. On the next one, domain. We know domain deal with x values. So the domain of this function is anywhere that we could try to wall it in from the left side to the right side. And you happen to notice with the left side, we have this kind of sharp looking arrow. And that arrow means that it goes on forever, both in a down and leftward position, which means realistically, we can't wall it in. That arrow would break right on free through this wall. Boom, so there's no wall over there. Which means the left side of this, all of the x values on the lowest or left side are trending towards the smallest number you can think of, -infinity. Okay? And -infinity is just a theory, so we put a parenthesis around it. However, on the right side, there could be a right wall right there, because on the right side of this graph, it ends at that dot right there. So what is the x location, the horizontal location at that dot? Boom, it's 3. So on the right side of the graph, it stops once we get to a horizontal movement of 3, and it does exist there because we could see it with that filled in dot. Therefore, it has a bracket around it. Domain from -infinity to 3. Cool, let's take a look at our range. Well, we happen to know based on this arrow again, that not only is this arrow going to the left forever, but it's also going down. And down forever means -infinity again. Sweet. So we can't really put a floor on it because it's going to keep busting through based on the arrow. We can put a ceiling on this, and the ceiling of this graph is going to be the highest point, which also happens to be that dot. And the height at this dot is 2. So our range goes from the lowest value down here, -infinity, to a height of +2, and it does exist there. All right, next up. At what values, at what numbers is g of x equal to 0? So what that's really asking is, where is our height? Our y value, 0. So let's cruise along this graph and see if we can find any spots on here where height is 0. Right there, right there, and right there. AKA, these are our x-intercepts. What are the values of x at these points? Well, -1. Let's kind of estimate that to be like 1/4. You could say like 1/3, 1/2. And then this one would be at a x value of 2. So effectively, our values of x that make a height of 0 or an x-intercept are those numbers, -1. I called 1/4, again, an estimation, and +2. All right, what values, for what function, what values, or sorry, for what intervals of this function is the graph increasing? And the increasing values are our positive slopes, aka the green and the purple pieces of this piecewise function. So the purple piece goes from -infinity, as we just mentioned, because of that arrow. So it goes from -infinity all the way up to where? Well, as we trend along this graph, we see that it goes all the way up and then turns right here, and that's at a x value of 0. So it stops at 0. And then it starts heading downhill in the blue. We'll get to that in a second. Then we move over to the purple. Then the purple turns from going downhill to uphill, from decreasing to increasing, and it is increasing over this entire domain right here. And it looks to me to be from x value of 1 all the way to an x value of 3. All right. For what is it decreasing? Well, the decreasing is the negative slope, or the blue. So basically we're saying from this point right here to where the turning point was. So keep in mind that we already said it increased all the way up to 0. So once it hit 0, it's still increasing, so we can't say it exists at 0. And then it started decreasing all the way down to about 1, but we already included 1 in this bracket, so we won't include 1 in the mix there. It goes decreasing from 0 to 1, but not including 0 to 1, hence the parentheses. Last but not least, for what interval is this constant? The constant function is where it's flat, and there is no flat part in this graph, so the answer to that is none.